Good afternoon. I'm Sameera and I'm located in Netherlands and I'm working as an integrity advisor at HDM Pipelines in Leeuwarden. Today, I'm going to present you an integrity management approach which we used to undertake a project for managing integrity of wastewater or sewer pipelines. Pipelines. So, if we hear the word pipelines and if we think only about oil and gas, I would have to say it is not completely correct because we have several other life saving pipelines like water and wastewater, which is beneath us. And they too require an integrity management and a good maintenance. This will definitely facilitate a healthy environment and a healthy human beings also. So, in this presentation, how do we? I would say, how do we manage the integrity and how do we maintain the aging wastewater pipelines? So, we have just in Netherlands, we have around 80,000 kilometers of wastewater pipelines, and there are different materials which are used in wastewater pipelines. For example, we have plastics, we have iron, cast iron, and we have steel. And along with it, we have materials like asbestos cement, which is, of course, we all know now it's dangerous, but our one generation before us, they did not know that. So they have put a lot of pipelines in the ground, and we have to manage it now. And we have also concrete pipelines. So, how do we combine our knowledge of integrity management by just assessing one material? It doesn't work like that. We have to assess several other materials, understand the whole mechanism of those failures or aging of these materials, and give an advice as an integrity advice consultancy firm. We have to give an advice to our clients so that they can maintain their assets which to be safe and good functioning. So, along how do we do that? It's challenging. Why? There is very limited condition data and also construction data. Not a lot of condition assessments were carried out through the several years of installation. And we have to start building up our data to begin with, but also along with that limited data, we have to give a safe integrity assessment. So that's the challenge we are facing now, and I hope we are doing well with this method which we present now. To understand our integrity assessment, we need construction, operation, the past and the present condition of the pipelines. Thus, for an example of a case study, we have our client, a pipeline operator in the south of Netherlands in the province of Limburg, have given us an opportunity to undertake integrity management of their pipeline network. We, as HDM Pipelines, that's my company which I represent, is our consultants of pipeline integrity. And we also worked with Acquaint, a pipeline inspection and monitoring company. We came together to assess the integrity of the network which WBL owns. To begin with, we have to understand the whole asset management scheme which WBL is using. First, to understand what they are doing, what they have been doing, so that we can fit our management plan into theirs so that there wouldn't be any conflict of interest, and also it will go on smooth. So that's the reason why we started to understand what plan they are using. Plan is pretty much very similar to several other integrity management plans. They start with asset inventory, they understand the asset, list out all the assets they have, they understand the performance and influences of several other parties and other assets surrounding the environment and so on. And then they analyze the risks and then they devise a safety measure of those pipelines, what measures they have taken and what they want to take based on risk assessments. And then they determine the cost, obviously, which is an important parameter. And then based on these risk-based risk assessments, they undertake the decisions. This is the plan which WBL have been using, and they want to keep this in the further assessment procedures. Our integrity management plan, which we want to build, it should come within this scope. So that's the first step we understood. And then we also understand the other uh, parameters. The main outcome of this plan is it should comply with legal obligations. So in Netherlands government have, like several other governments in the world, have put on some uh, measures and also some rules which these assets has to comply with, so that they can stay in operation. And those rules should, our integrity scheme should comply with these rules. And then obviously people and environment, they should be safe with these rules. So that's also something which we have to keep it in our picture, and obviously prevent any occurrences, unusual occurrences like leakage, burst, or stopping or something like that, blockage. And then if there is a consequence which we can never uh, which are never predicted, sometimes obviously it happens, and those consequences should not have a major effect on any of the surroundings or even the company. So these things are main target for us to do all the integrity assessments. So how do we begin with? Obviously, like fitting into the asset management plan of WBL, we start with risk inventory and evaluation. We understand the risks in the beginning, in the current situation, and also in the future situation. But to begin with, we start with initial situation, understand the risk, and evaluate those risks. And then, based on risk, RI and E, we do inspections, inspection of the pipelines. It could be inline inspection or any sort of other inspections. We do the supervision. We go on the site or understand interviews and so on. We understand what WBL is doing and what are the assets. And then we assess the data from inspection, risk, and supervision. We evaluate those things, take some parameters, understand the condition of the pipes by using several calculations, strength calculations, and so on. And then we check those calculations based on operating procedures, standard operating procedures, which I mean here, the standards, norms, and so on. We compare, are we within those norms? And does it make sense? Is it over conservative? Is it not conservative at all? We check it. Then we give an advice to our client based on all this evaluation. And then we go again forward with risk inventory and evaluation after a certain time passes or depends to under the current situation or future situation. It's a continuous process. So that's the reason why we say it's a management concept of plan do check act cycle. We use it, and then we continuously monitor the asset based on this integrity management plan. And of course, it's a continuous process. To give you an example, in this presentation, in this paper, we took an example of one pipeline passing from Münster-Helene, a south province, which are marked in red here, province in Limburg. Münster-Helene is a city, and it passes till Hunsbroek. And there are different pumping stations in between in Helene and Schinnen. There are mainly three different materials or two different materials, asbestos cement and concrete in this pipeline. Asbestos cement, yeah, we'll talk about it. It's installed in 1988. It's a 500 diameter, inner diameter pipeline. Along with it, we have a concrete, which is wire reinforced, and also we have plate reinforced concretes in some sections. So they are 900 diameter pipelines, and it was installed in 87 and 82 respectively. So this set of or this pipeline, we are going to implement our integrity management approach and understand the condition and also further steps on these pipelines. So we have three steps basically to start with. We started with understanding the risks, what risks these pipelines are facing, and we evaluated those risks by giving the number, which is very common in several pipeline industries. And we use a similar concept to understand the risks. And then further, we did some inspections on these pipelines. The type of inspections I will be explaining in further slides. And then finally, our condition assessment of these pipelines, which gives the input to the further decision making for our clients or operator. To begin with risk inventory and evaluation, the process is pretty much straightforward, I would say. We have a pipeline. We we have certain techniques where we do sections of these pipelines based on each section of pipe, which is 5 meters. We collect the pipeline data itself, geographical information from the surroundings of the pipeline, the pumping stations, the measures they have taken, the jacket pipes or whatever, the roads and forests and so on. And then we list out the possible risks. The risk, I mean, is the possible causes of failures in these pipelines. We list it out and we understand other data of inspections, what standards say about it. We have some research on these risks, and we also have a lot of people who have quite a bit experience, and these input from all these are combined and they are translated into numbers, and those numbers are used in the cause and effect diagram, which is finally used to calculate the one value of one number of a risk, which can be used to assess which section of a pipe is at high risk or which is at low risk. We have this bow tie diagram, a common one indeed, and what causes we check are hydraulic functionality, we have pipe condition itself, and the location of the pipe. And then we have the effect. As usual, we have safety, environment, and costs, and so on, so forth. So all these measures we took for the prevention and also the after the failure are the repressive measures. So all these are also considered. And then finally, we have the likelihood of those risks and the impact of those risks are also considered in this bow tie diagram. And we have assessed all these parameters and came to a result stage where we have to fit all these results into the matrix of WBL itself. They have a standardized matrix of how they visualize the risks, how the asset manager will take a decision based on such a certain table. And that table was considered here. An example is given here. So we have this table where we see a risk area where we have accumulation of the fat. So that's an example in a very common problem in wastewater pipelines. And we consider the section where a pipe is crossing under the road. And what happens under the road? What are the chance of that risk occurring? It may occur in 2 to 5 years, for example. And then we come towards the effect of those things. Is for safety and health, it's minimum. And environment, very little. Cost, also very little. But for working conditions, it's dangerous. So what should we do? Then we go further, we'd say, okay, this is something good. What measures would be taken? The asset managers, the project managers comes in between and give a decision on how or what could be done on this. So this is an example of a table, and it may not be realistic, but this is an example on how the WBL is using their risk matrix to make certain decisions. We did the same on this pipeline, and it was the matrix said that we need to undertake a better assessments, we need better knowledge to understand the condition of the pipeline, and then the inspection and condition assessments were undertaken on this pipeline. this pipeline. But obviously, in this current stage, what we do is we actually give a map, interactive plot where the risk can be visualized. And when this project was undertaken, we were not yet giving this service, but of course, this is how we visualize our risk at this stage with a depth profile and also a geographical map. I wouldn't go further there, so I would go further with inspections, how we did, what inspections we did, and so on. To begin with, we did an inline inspection. Our partners, Acquaint, used their unique tool, a state-of-art inspection tool, where they measured wall thickness, ovality, joint displacement, if there are any leaks, they detected the leaks, joint width and wire breaks in asbestos, concrete, and any other plastics or steel pipes. So they used this tool. Ultrasonic sensors were there, and they had also for certain materials they had magnetic field wave sensors too. And this is the inline inspection, a short view of this. So they use this, and certain these data which are mentioned here are obtained. And we collected as HTM as a consultant, we collected this data and for condition which will be used for condition assessments. Further, certain coupons were extracted at certain locations which showed high risk locations. So at those locations, coupons were extracted, and these coupons acted as validation of inspection results. We could see degradation mechanisms in the material, concrete, asbestos, and we did few tensile tests for asbestos cement pipes so that we understand the material strength. And we also did phenolphthalein test, which showed the degradations in the material. So, an example of a asbestos cement pipe or a coupon on the left, and on the right is a concrete coupon. Here we see a degradation in the pipe in the asbestos cement section. Degradation obviously reduces the strength of the pipe, which is reducing the wall thickness, and thus we have to understand based on strength calculations what is the current pipe's condition on this degradation and so on. And obviously, concrete has a different types of degradation mechanism. There are some porosities and so on. It rusting of wire or reinforcements, and these mechanisms could be seen or assessed through these samples. And after these two types of inspection, we move towards condition assessments using the data from inline inspection and also the data from the coupons we used. We went through the strength calculations. To do the calculations, we started gathering again the geographical data, the roads, water, buildings, soil, the type of soil, the weight which it could put on the pipe, the ground, the water levels, and so on. Netherlands has a good open data policy where we can get several data, a lot of information on the geography of Netherlands. And this will help us to understand better the condition of the pipe by making the strength calculations. And obviously, we need this pipe specific data. When was it installed or when was it manufactured? What material is it? The diameters, the thickness of the wall. In the initial stage, in the current stage, we did the inspections. But in the initial stage, is also important. The strength of the material, what was it assumed initially and what is it now? And further the information. We also took information from wall thickness, the degradation, the abnormalities, and displacements in the joints, and the cracks in the pipe and so on. We collected all the information, whichever was available. And then basically very straightforward strength calculations. We assessed the internal pressure, the effect of internal pressure, the effect of external loads of the soil or the buildings and so on. And then we also have the side loads due to different parameters, I would say. And these loads should basically be lesser than the allowable stress. or the allowable strength of the pipe, which we tested, or from the manufacturer. So this concept we used, and we used the Dutch standards NEN to calculate these stresses, and we further show what, for an example, we would say how what's the condition of this joint. Are the stresses within the limits or not? How could we check? Is basically we check the beam calculations, and then we check different stresses in the top, bottom, and middle, and on the ring side, and also due to the side loads and so on. And if any one of these stresses are dangerous above the limit, then we would have to say it is something which requires attention. If it And we could quantify based on the stresses. For example, for an asbestos cement NEN standard says the allowable stress is 10 MPa. It's based on safety factors and so on. Here we have higher loads. So we have to be careful in this location. We have to understand, is this good? And the second thing is, are we being conservative? So these two things we have to weigh upon and discuss with the asset managers, take the previous data of failures and so on, and then make a decision on these points. If they are all green, we would say we are already in the conservative side and still it is green. That means it is safe for operation. And remaining life, we calculate the remaining life based on degradation curves for materials which have degradation. And we have an initial degradation, initial wall thickness, and then at current stage we have certain degradation which has reduced the wall thickness. And when could we expect in the future it will fail based on these degradations? So that's a material for asbestos cement. We could predict something like this. But for concrete or any other material, there are other mechanisms we have to understand and then predict the remaining life of those pipelines. So we consider different data of manufacturer inspections, from testings, and other experience from the experience of people. We have to combine this, and only then we could predict a good remaining life of the pipe. And for decision making, for this particular pipe, what was the decision which was obtained of what was the output which was obtained from these condition assessments? We had asbestos cement pipe, which needed attention. So we recommended that the prioritization should start to make replacements because the level of degradations were quite high. And for concrete pipes, it was in good condition. There were some spots where H2S, hydrogen sulfide attack, which is very common in sewage pipelines, had occurred, which leads to damage of the pipelines within the walls. And those points had to take measures. There was some severe attack, and those replacements should be made. In some locations, it was in the beginning phases, and thus they could also think of monitoring those locations and then make a replacements in certain number of years in the future. And obviously we had to plan regular inspections of those pipes so that this H2S, which is a very quick attack, could be monitored and prevented and maybe replaced also if it's very dangerous. And the similar thing we observed was plastic pipes. They're relatively new and they were in good condition. Some ovality was observed, and obviously it could be also due to in the initial phases when they were laid on the ground. So there is quite a lot of settlement issues in Netherlands, the ground settlement, and those should also be monitored, which we can do with open data, and thus we should monitor it through the number of years. And at this stage, we didn't have a severe ovality, and thus the pipes were in good condition. And finally, we always recommend to have a good inspection planning schedule so that safety of this pipe can be guaranteed. And with this, we consider this as a very good approach to understand every aspect of this pipeline. Obviously, there are further more aspects to understand with cost effectiveness and cost limitation of our clients, and also uh, the pipe condition at this stage itself did not require such a several testing. We say this condition or integrity approach assessment approach was quite good, and we could convince the experienced managers, asset managers, that this procedure was almost on target, and thus we say we could say that our pipelines could be safe, and we have reduced the conservativeness, and we have increased the cost effective inspection or integrity management approach, and finally we are sure that uh, it will be within the legal limits. It will, and it will help the safety of our personnel and also the assets. And I'm sure there will be a low impact if there are any events, unpredicted events of failures. Thus, I would like to end my presentation for, and I hope this approach is good and it can be used in further, it can be used further, developed further by our friends all over the world. Thank you.